Hi friends, today we discussing about the Ohm's law. Means Ohm's law definition, Ohm's law statement, Ohm's law formula, experimental verification of Ohm's law, voltage and current graph, relationship between voltage, resistance, and current, limitations of Ohm's law and applications of Ohm's law. Ohm's law was given by German physicist Georg Simon Ohm. It states the relationship between current, resistance, and voltage across an electrical circuit. This relationship between current I, voltage V, and resistance R was given by famous German scientist Georg Simon Ohm in 1827. He found conducting his experiment that the product of the current flowing through the conductor and the resistance of the conductor determines the voltage drop over that conductor in the circuit. We know the definition of voltage V. Voltage is the electrical potential difference, or push, that causes electrons to move. Next, we know the definition of current I. Current is the rate of flow of electric charge, measured in amperes. Next, we know the definition of A. Resistance R. Resistance is the opposition to the flow of electric current, measured in ohms. Ohm's law provides a fundamental framework for understanding and analyzing electrical circuits. It's a cornerstone of electrical engineering and physics. Next, we discuss about the definition of the Ohm's law. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperatures remain constant. Hence, according to Ohm's law, the current flowing through the conductor is directly proportional to the voltage across the circuit, that is V is directly proportional to the I. Thus, as Ohm's law provides the basic relation between the voltage applied and current through the conductor, it is considered as the basic law which helps us in dealing electric circuit. Ohm's law states that the current follows a linear relationship with voltage. In simple terms, Ohm's law is one of the fundamental laws of electrostatics which state that the voltage across any conductor is directly proportional to the current flowing in that conductor. We can define this condition as V is directly proportional to the I. Removing the proportionality sign, V is equals to IR. Or V is equals to I into R, where R is the proportionality constant and is called the of the material. The resistance of the material is calculated as R is equals to V by I. Resistance is measured in ohms. It is denoted by the symbol ohm, means the uppercase Greek letter omega. So, according to Ohm's law states that the voltage V across a conductor is directly proportional to the current I flowing through it, with the proportionality constant being the resistance R of the conductor. This relationship can be expressed mathematically as V is equals to IR. Next we discussing about the Ohm's law statement. The statement describes Ohm's law, a fundamental principle in electricity. Ohm's law states that the current I flowing through a conductor is directly proportional to the voltage V applied across it, and inversely proportional to its resistance R. This relationship is expressed as I equals to V by R. This proportionality holds true when the temperature and other physical conditions of the conductor remain constant. Direct proportionality means, if the voltage across a conductor increases, the current flowing through it will also increase, and vice versa, assuming the resistance stays constant. Inverse proportionality means, if the resistance of a conductor increases, the current flowing through it will decrease, and vice versa, assuming the voltage stays constant. Constant temperature means, the relationship in Ohm's law is most accurate when the temperature of the conductor is kept stable. Changes in temperature can affect the resistance of a conductor. In simpler words, Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through it and inversely proportional to the resistance of the resistor. It is often used to calculate one of these parameters, V, I, or R, when the other two are known in an electrical circuit. It means, for calculating voltage, V equals to IR. For calculating current, I equals to V by R. For calculating resistance, R equals to V by I. Next, we discuss about Ohm's law formula. Ohm's law formula helps to show the calculations that are required to solve for voltage, current, and resistance. Under the condition that all physical parameters and temperatures remain constant, Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it. Mathematically, Ohm's law is expressed as V equals to IR, where R is the constant of proportionality known as resistance. Electrical resistance is measured in ohms, symbolized by the Greek letter omega. It's a measure of how much a material opposes the flow of electric current. V is the applied voltage. Voltage is measured in volts, often abbreviated as V. It represents the potential difference between 2 points in an electrical circuit, essentially the pressure that drives electric current. The unit is named after Alessandro Volta, an Italian physicist who invented the first battery. I is the current flowing through the electrical circuit. Electric current is measured in amperes, A, also known as amps. An ammeter is the instrument used to measure current. The definition of current is the rate of flow of electric charge, specifically the flow of electrons in a circuit. The ampere A is the standard unit of electric current in the International System of Units, C. An ammeter is a device specifically designed to measure current, and it's calibrated in amperes. A current of 1 ampere means that 1 coulomb of charge, which is the equivalent of 6.24 billion electrons, flows past a point in a circuit every second. Next,
we discuss about the experimental verification of Ohm's law. Ohm's law can be easily verified by the following experiment. The image depicts a circuit diagram illustrating Ohm's law. Ohm's law defines the relationship between voltage V, current I, and resistance R in an electrical circuit. It states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. The formula for Ohm's law is V equals to IR, where V equals voltage measured in volts, I equals current measured in amperes, R equals resistance measured in ohms. The circuit diagram includes the following components. R means resistor, providing resistance to the current flow. A means ammeter, used to measure the current flowing through the circuit. V means voltmeter, used to measure the voltage across the resistor. B means battery, providing the voltage source. K means key, switch, used to open or close the circuit. RH means rheostat, a variable resistor used to control the current. Ohm's law is a fundamental principle in electrical engineering and physics. It is crucial for understanding and designing electrical circuits. Next we discuss about the procedure of the circuit diagram. In an Ohm's law experiment, initially closing the key, K, and adjusting the rheostat to obtain the minimum readings on both the ammeter, A, and the voltmeter, V, sets the stage for observing the relationship between voltage and current. This step establishes a baseline with current flowing through the circuit. The rheostat is then adjusted to increase the current gradually, with measurements of voltage and current taken at each step. In a circuit, a rheostat, which is a variable resistor, is used to control the current by adjusting the resistance. By gradually moving the sliding terminal of the rheostat, you can increase or decrease the resistance, which in turn affects the current flow in the circuit. This is a common method for experimentally verifying Ohm's law and other electrical principles. During the process, the current flowing in the circuit and the corresponding value of potential difference across the resistance wire, R, are recorded. This way different sets of values of voltage and current are obtained. For each set of values of V and I, the ratio of V by I is calculated. Thus, for various settings of a rheostat, the reading of the voltmeter and ammeter are noted. From the monitoring, it can be seen that the ratio of voltmeter reading and ammeter reading always remains the same every time. That is, V1 by I1 equals 2, V2 by I2 equals 2, V3 by I3 equals 2, V4 by I4 equals 2, V5 by I5 and so on, that equals to constant equals to R. Simply, V by I that equals to R means V equals to IR. Hence Ohm's law proved. Next we discuss about the V and I graph, also known as a current voltage characteristic graph, depicts the relationship between voltage V and current I flowing through an electrical component or device. The slope of the graph represents the resistance, and for a linear graph, the slope indicates a constant resistance. The image illustrates Ohm's law, which describes the relationship between voltage, current, and resistance in an electrical circuit. Ohm's law states that voltage V is directly proportional to current I when resistance R is constant. The formula is V equals to IR. Graph interpretation. The straight line in the graph indicates a linear relationship between voltage and current, confirming Ohm's law. According to Ohm's law, if the temperature and physical conditions of a conductor are constant, the current through it is directly proportional to the potential difference across it. Simply, it states that for a conductor, if temperature and other physical conditions are kept constant, the current flowing through it is directly proportional to the potential difference means voltage applied across its ends. This relationship is mathematically expressed as V equals to IR, where V is the potential difference, I is the current, and R is the resistance of the conductor. This means that if you plot voltage V on the x-axis and current I on the y-axis, the resulting graph will be a straight line passing through the origin. In simple terms, a voltage-current characteristic graph VI graph can be plotted, with voltage on the y-axis and current on the x-axis. The VI graph is a straight line that passes through the origin. This shows that the current and voltage are proportional. As one variable increases, the other does at the same rate. The slope of this line represents the resistance of the conductor. It means, the slope of the represents the resistance of the conductor as in the graph above is based on the Ohm's law. We know that V is directly proportionality to I and V equals to IR. Also, the slope of the graph represents R equals to VI and it is known as the resistance of the conductor for which the graph is represented. A straight line plot shows that as the current through a wire, the potential difference across the wire increases linearly. This is Ohm's law. The potential difference across the ends of a resistor is directly proportional to the current through it, provided its temperature remains the same. The resistance of a conductor depends directly on its length, inversely on its area of cross-section, and also on the material of the conductor. Next, we discuss about the Ohm's law relationship between voltage, resistance, and current. The current passing through a conductor is directly proportional to the voltage across the conductor is called as Ohm's law. It means, Ohm's law describes the relationship between voltage, resistance, and current in a circuit. It states that the current flowing through a conductor is directly proportional to the voltage across the conductor and inversely proportional to the resistance of the conductor. This relationship is represented by the equation V equals to IR, where V is the voltage in volts, I is the current in amperes, and R is the resistance in ohms, which describes the relationship between voltage V current I and resistance R. For calculating voltage V equals IR, it means Ohm's law equation V equals to IR, where V is the voltage across the conductor, I is the current flowing through the conductor, and R is the resistance provided by the conductor to the flow of current. For calculating current, I equals to V divided by R. The relationship between voltage, current, and resistance is described by Ohm's law. This equation, I equals to versus divided by R, tells us that the current, I, flowing through a circuit is directly proportional to the voltage, V, and inversely proportional to the resistance, R. For calculating resistance, R equals to V divided by I. This formula tells you that your resistance is always equal to your voltage divided by the current. You can also say that your voltage is equal to your current multiplied by your resistance, or V equals IR in equation form, with R equals to V divided by I. The image represents Ohm's law, a fundamental principle in electrical circuits. It describes the relationship between voltage V, current I, and resistance R. The triangle visually aids in recalling the formulas. Voltage V, the electric potential difference, measured in volts. Current I, the flow of electric charge, measured in amperes. Resistance R, opposition to current flow, measured in ohms. Formulas. V equals to IR, voltage equals current times resistance. I equals to V divided by R, current equals voltage divided by resistance. R equals to V divided by I, resistance equals voltage divided by current. Ohm's law is valid when physical conditions like temperature remain constant.